All right, hello there. So we're going to go through and do solving these radical equations to start off our next chapter. So you've done this in Algebra 2, but you probably only did it with square roots, so we just have some roots that are a little bit higher. And I do have one fix to tell you about here. I mixed up these numbers here. This should be a 4 on this problem you're going to do, and this should be a 3. I switched them around by accident. So anyway, you're going to do that problem and tell me the answer in class next time. All right. So to solve these equations, notice that my problem, I do remind you to check for what are called extraneous solutions, so I'll be talking about that soon, but let's start with letter A. So let's take away 3 from both sides to clean this up. I have the fourth root of 4x plus 8 equals 2 now. And so now, just like you did in Algebra 2, when you see a radical, you do a power. And so if I do the fourth power on both sides, it cancels out the fourth root. Right, so 2 to the fourth is 16, and this fourth power knocks out the fourth root. So remember, a fourth root is like a 1/4 power, and you're multiplying that by the fourth power, so they're knocking each other away. So you get 4x plus 8 to come out. So I'm going to take away 8 from both sides, so I get 4x equals 8, and I get x equals 2 to finish off. So to check for extraneous solutions, you should just mentally kind of think through if 2 is my answer. So that'd be 4 times 2 is 8, 8 plus 8 is 16. Well, the fourth root of 16 is 2, and 2 plus 3 is 5, so it works. All right, and the extraneous solutions don't happen often. What happens is that if you mentally check it and it's not correct, then you just got a fake answer. That's what extraneous solutions mean. So sometimes with these radicals that happens. Let's see. For letter B, I'm going to clean this up, take away 14. 14, sorry. Oh no, I just messed up everything. All right, so I ended up getting 36 over here, and I have third root x minus 5 squared. Now, I have one of two things I could do here. I could do the cube power on both sides, but the cube power of 36 would be really huge. And then I notice I have that square right there. So remember in Algebra 2, another way to write this radical with a third root and a square power there would be to write x minus 5 to the 2/3 equals 36. So remember, when you write this, you take the power and you put it over the root, so you make that a fraction. Like if I have x to the 3/4, that would be x to the third power, and I would put a fourth root around it. Okay? All right, so if I want to combat the 2/3 power, what I could do to both sides, or what I would do to both sides, is I would do a 3/2 power, because it's the reciprocal. And what that does, the 3's cancels, the 2's cancels, and so that makes x minus 5 pop out. And then I have 36 to the 3/2. Now you might be thinking 36 to the 3/2, yuck. So, but you can, just go right over to Desmos, and I was just in here doing this, so hopefully, oh good. So I have 36, and then put a power, and then put 3 divided by 2. And there's your answer. Okay, now let me teach you a little minute about why that comes out. So if I did 36 to the third power, I got this big number. Oops. Why did it do that? All right, so there's the answer, 36 to the third power. And then I did the square root of that. So I did the square root, because that's what the half in there means, of 6656. And the answer is 216, same thing. But another way, the reason we like to break it up like this is because of this. Instead of doing the third power first, you could also do the square root first, because 36, the square root of 36 is easy for you. You know it's 6, right? So I could do the square root of 36 first, because that's that 2 on the bottom. And then I could take that answer, and I could do the third power on that, which is not as hard to do, and still get 216. So either way you want to think of it, you can just type this in your calculator, or you can understand the square root of 36 is 6, and then 6 to the third is 216. That would be the easiest way to think of it if you didn't have a calculator around. All right, so 216 is all we need to know from that. So let's see, I have x minus 5 equals 216, and then add 5 to both sides, so I get 221. All right, so let's just mentally check that real quick. If I put 221 right here, 221 minus 5 is 216, and 216 to the 2/3 is going to be 36. And 36 plus 14 is 15. All right, over here, this is the easiest problem we have, because I have a square root on both sides. So technically, I'm going to square both sides. But really I could just notice, hey, the inside parts have to be equal, because when I square both sides, 3x plus 7 pops out, and so does 2 minus x. So basically, when you have matching roots, so they have to be matching to do this, but these are both square roots, so they both have to be cube roots, square roots, fourth roots, whatever, to do this. All right, so let's just add x to both sides. So I get 4x plus 7 equals 2. Take away 2, or 7 I mean, so you get 4x equals negative 5, so my answer is negative 5/4. All right, so that's kind of like an annoying one to check over, so I wrote it, to plug that back in. So I wrote it on the next page here, negative 5/4. So I'm trying to see if negative 5/4 works in these two parts of the problem. So I put negative 5/4 in here. I multiply that out, but I notice, oh, I need a common denominator. So let's see, 7 is really 28 over 4, because that's 7. So when I add those up, I get 13 over 4. All right, so check out here. Put negative 5/4 in here. So 2 negatives turns to a plus, and so 2 in terms of fourths would be 8/4, because 8/4 is 2. Add those up, 13/4. So they're the same. So this was not an extraneous solution. Whoopsie. All right, so last problem here. All right, so you're going to do letter E later and give me the answer in class. So in this last problem, notice this 1 is over here on the right. If I move that 1 over on the left side, it turns into x minus 1. That way I get my square root alone. And that way I can square both sides really easy now. So when I square both sides, this pops out. But this is going to be a little bit harder on the left side. We haven't had one like this. So I have x minus 1 squared equals 2x minus 2. So I have to literally square this out, which means I have to write it twice. Don't just square both parts. That's not how it works. Remember, you have to FOIL it. If you square both parts and you say, oh, the answer is x squared plus 1, you're going to be missing a part, and here's why. So I know x times x is x squared. Here times here is negative 1x. Inside is negative 1x, and this part is plus 1. So 2x minus 2. So I get x squared minus 2x plus 1. So notice x squared and 1 are part of your answer, but you would be missing this minus 2x, which is a vital part of your problem. So I get 2x minus 2. All right, so I'm going to wrap this over here. I'm going to take away 2x from both sides. So I would get x squared minus 4x plus 1 equals negative 2, because I was taking away 2x here and take away 2x there. All right, so then I'm going to add 2. So I get x squared minus 4x plus 3. So hopefully you remember from Algebra 2, you got to factor this to solve it. So I got x and x. What multiplies to 3 and makes 4? Well, that's 3 and 1. Both negative. All right, so my answers are 1 and 3. So I just got to check that out. If I plug 1 into here, that'd be 2 times 1 is 2. 2 minus 2 is 0. So I'm getting a 0 from this part. And if I plug 1 into here, then I would get 1 equals 1, because that part's 0. Okay, 3. So 3 equals 1 plus radical 2 times 3 is 6 minus 2. So that would be a square root of 4. Square root of 4 is 2. So 2 plus 1 is 3. So that checks out too. All right, so they're both correct. All right, so again, you do letter E, and I'll see you in class. Bye-bye.